All right, everybody, we are now in chapter 4. This begins the reverse process of everything we learned so far. We were doing derivatives before, so now we're going to do integration, which is the exact opposite. So if we have the derivatives equal to 3x squared, what is f of x? Just wait a sec here. If you said x cubed, you would be right, but there are an infinite amount of answers. Okay, so it could be x cubed. It could also be x cubed plus 1, or x cubed plus 7, or x cubed plus, let's not do plus, let's do minus 100. Because when you take the derivative, all of these constants go to 0. Right? So all those functions give us this. So because the derivative of a constant equals 0, when we do a question like this and find the original function, we say f of x is going to be x cubed plus c, and c can be anything, and this is called the constant of integration. Okay. So the formal way to say this, let's get out of this green like that, is the antiderivative, okay, of f of x equals 3x squared is x cubed plus c, right? This is called the antiderivative. All right, now there's a mathematical way to write this, is we say y, or we could write f of x, is equal to the integral. This is a general form, so this f of x is different. Dx is equal to capital F of x plus c. All right, now, so a couple, obviously some new notation here. This is called an integral sign. Okay, and we'll talk about why it's squiggly in a bonus lesson that I will do. F of x is the function being integrated. And then this is the variable of integration. And as we said before, this is the antiderivative of f of x, little f of x. Okay, so when you do an integral, basically you're finding the antiderivative. Now, how do you do this? Well, some of you have probably already figured it out or have seen it before. So there's obviously a set of rules. This is rules for everything. First one, you are integrating 0. Basically what I'm asking you is the derivative of what function will give you 0? Huh? any constant. Be anything. 1, 2, 3, 8, 9, -10, -1 billion. Second one, if, that's a bad integral sign. Okay. K is a constant, okay? If you have a constant on the integral sign, you can pull the constant out. And then integrate the function as normal. So constants can be pulled out. You can only pull constants out. You cannot pull functions, all right? Third rule, and this is the big one. Integral of x to the n dx. Well, can you figure it out? We went from 3x squared to x cubed. When we're doing the derivative, we always take 1 away from the exponent. Remember, we would go -1, and that gives us the 2. After we drop the 3 down. Opposite way, you're going to add 1 to the exponent. So this would be x to the n plus 1. And you're going to divide by that new exponent, plus 1, plus c. Okay? In this case, we'll learn it later on, but for now, n cannot equal -1. All right, we'll learn why that, we'll learn why that is in a bit, and we'll learn how to deal with that as well. But for now, we're not going to deal with n is equal to -1 here. And the fourth one is around trig ones. There's no real rule here. Cos x dx, i.e. the derivative of what function gives you cosine? Well, that's sine x plus c. And if I asked for the integral of sine x dx, i.e. the derivative of what function gives you sine, it would be negative cos x plus c. I will post the integration rules just like I did with the derivative rules when I post this lesson. So, but those two are fairly common. You should be familiar with those. And again, when you go to university, you don't get anything. So in this class, you will. Okay, it doesn't want to work. All right, so let's do practice questions. Start with the basics. Yeah, yeah. Well, we know that the 3 can come outside. So then what do we do here? We use this rule right above it. Add 1 to the exponent. So that's going to be x squared divided by the 2. Always put a plus c. And then this 3 in front. Throw a 3 up there. You're done. How could you check it? Do the derivative. Drop the 2 down. Cancels that. And you get 3x. Second one. What if you have something like that? Well, obviously, you don't want to deal with the fractions. So split it up. And then you can use this rule up here. Add 1 to the exponent. -3 plus 1, -2. Divide by the -2. Throw in a plus c. You could leave it like that. You could flip the x squared down. That negative could be up top. There's like 3 different ways you can write this. This would probably be the best way, but any of those are correct. All right. What if you have a root? Obviously, we don't want the root. We want to get rid of the square root. So we write it as an exponent. We always want to x 1/2 dx. Add 1, so you're going to have to be comfortable with fractions. If I add 1 to this, okay, none of my other colors want to work here. Okay. So I'm going to add 1, which is 2 over 2. So I'm going to x to the 3 halves. See, I have to divide by 3 halves, which is really just like 2x to the 3 halves over 3 plus c, as you flip the bottom fraction. Integral of 1x. Yep. Okay. Pull the constant out. Negative 5. What derivative of what function makes sine x? Well, that's negative cos x. So the answer is negative 2 cos x. Always remember your plus c. What about this? Derivative of what function is 1? Well, that's just x. So that's just x plus c. Okay. Here. Why does he have a big long function? 3x to the 6, 7x squared minus 9x plus 4. Well, treat each one individually. You can break them all up. So you can do it as 3x to the 6 dx, 7x squared dx minus 9x dx plus 4. Sorry. I got room here. Plus 4 dx. And then there's each one separately. You don't have to pull the 3 out. You can just go x to the 6, add 1 is x to the 7, divided by 7. It's 3 over 7, x to the 7, plus add 1 to this 2, 7x cubed divided by new exponent, minus 9x squared over 2, plus 4x, and always remember your plus c. 7. What about something like this? X plus 1 root x dx. Well, again, you want to rewrite it. We don't like square roots, and we don't know how to do fractions yet. So we can rewrite this. The single denominator goes to both. So I can rewrite it as x over x to the 1/2 plus n over x to the 1/2, which this first one simplifies to x to the 1/2, and I should have had a dx there, and a dx there, plus, flip that up, that. And then I can integrate them, or find the antiderivative. So add 1 to a half, I get 3 halves, divide by 3 halves, and I get 2 over 3. Add 1 to negative a half, and then you get 1/2. Divide by a half is the same as flipping it. Tack on the plus c, and you're good to go. Alright, let's do one slightly more complicated one. So the integral sine x over cos squared x dx. So when you're doing trig, if it doesn't match, so here's our trig bar rules that I will post. Basically, we're looking at all these things here. All right. You want to make it match whatever's in here. Okay. So obviously, this one does not match. It's got sine over cos. We have to rewrite it using our trig stuff. I'm going to rewrite this as integral sine x over cos x times 1 over cos x dx. That's the exact same thing. Now I just broke up this cos squared. Sine over cos is tan of x. 1 over cosine is secant x dx. Then you go to, can't do anything else in that. Secant x times tan x is equal to, the integral of secant x tan x is equal to secant x. So this becomes secant x to c. We're not going to worry about how this happens. That's later on in the course. But just make your integral match something that is on the formula sheet. Okay? So this will be a point in the class where I give you some time to work on questions. Questions I would want you to do for this are page 251, numbers 11 to 33 odd. I'll give you some time to do that. And then, why is this not working? Right. And then when you've done that, we're going to move on here. So, what do you do when you actually want to know what C is? Well, you need some more information. And this is called finding a particular solution. So, f prime of x is going to equal 3x squared minus 1, and f of 2 is equal to 4. So I know what the derivative is. I know the original function passes through the point 2, 4. That's our x, that's our y. I want to find the solution. Okay? Find f of x. Right. So first, I have to integrate this. So 3x squared minus 1 integrated with respect to x. Add an exponent to this 2, divide by 3, so basically you get x cubed. Negative 1, the antiderivative of that is negative x. And then always a plus c. Okay? I need to get rid of the c. Okay? So this is called the general solution. Right? I have the general answer. It can be anything because there's an infinite number of answers because the constant could be anything. But they have told me what x and y are here. So I know if I go f of 2, so I put 2 in for all my x's, 2 cubed minus 2 plus c, all of that should equal 4. And you solve it. 2 cubed is 8, minus 2 plus c is 4, 8 minus 2 is 6, so c is equal to negative 2. So the particular solution is x cubed minus x minus 2. And that is your final answer. All right, I guess I have time to do this last question. All right, from people out there. All right. Throw a ball up. Space. Yeah. So this is basically right out of the book. Thrown up with initial velocity of 29 meters per second. From a height, sorry, from a height of 40 meters. What is the position function of the ball? What is the position function of the ball? I.e., what function will describe where the ball is at any time? All right, so drawing. This is 40 meters. They throw a ball up at 29 meters per second. So I know that the velocity E of 0 is equal to 29, and we know that velocity, actually, I'm going to use h, is actually the first derivative, right? So the first derivative is equal to that. We know that gravity, physics people, is pulling down on it, right? So g is equal to negative 9.8 meters per second squared. And we know that acceleration is the second derivative. So h double prime of t is equal to a of t, and that is equal to negative 9.8 meters per second squared. Okay, so starting with the acceleration. If I integrate the second derivative, i.e. I'm integrating a of t, I should get h prime of t, which is equal to velocity function. So let's do that. I integrate negative 9.8. I'm going to get negative 9.8 t plus c. That is my first derivative or my velocity function. All right. I don't want the c. How do I get rid of the c? Well, this is velocity function. What did I say up here? I said that when the initial velocity is 0. So v of 0 is negative 9.8 and 0 plus c. That was 29. So that goes away. So c is equal to 29. Okay. So now I know the particular velocity function. So I know that v of t now is negative 9.8 t plus 29. Now to get the position function, if I integrate the velocity function, which is the same as integrating h prime of t, because that is the first derivative, I should get h of t, which is my position function. So let's do that. So we're going to integrate negative 9.8 t plus 29. What is that time? And it gives me negative 9.8 t squared over 2 plus 29t plus c. If I figure out what I'm going to do here, well, I'm going to solve for c because I know that my initial height at time 0 is 40 meters. So I go, and this is h of t, and if I do h of 0, negative 9.8, 0 squared over 2, plus 29 times 0, plus c, that all equals 40. Therefore, c is 40. So the actual function, h of t, is negative 9.8 t squared over 2 plus 29t plus 40. That is your position function. And if you know physics people, that is essentially 1/2 a t squared plus v naught t plus your initial height. I'll just put height, which is your physics formula I'm sure you've seen before. And that's where it comes from. All right. Questions I would like you to do are page 252, numbers 35 to 41, odd, and number 53. All right, that's the beginning of integration. Hope if you have any questions, please email. All right, have a good day.